I'm Roy Visser of the Technokats, and we're going to talk today about how to prepare particularly a young team to build a winning robot. There are several aspects to the design process of how do you decide what to do. There's the software team, there's the electrical hardware team, and there's a mechanical team. I'm going to emphasize talking about the mechanical team because I know that part best. Alan and of course Mike would know the software and electrical better. But there's two parts to the mechanical task of building a robot. The first is design and the second is fabrication. This team is just like any other sports team. It gets good at what it does through practice. If you joined the basketball team, for example, and you didn't practice basketball game until your first game, then you would probably not do very well on your first game when you just show up. People wouldn't be sure what their role was, and that's kind of what the purpose of this is. In the mechanical role, in the mechanical area, there are two roles: design, of course, and build. The way we get good at building is by learning how to use the machines. And there's two ways to do that. One is to try to teach you by talking a lot, which I'm not very good at. The second way that I prefer is to learn to build by doing things, by building something. We have several projects in mind now, and it's nice if the projects use the techniques that you use in fabricating a robot. For example, if you do a lot with bolted together aluminum channel, you might want to use that technique when you are building your practice parts. A second part of the mechanical design process is actually doing the design. And I like to think of this the way I was taught in college. The highest level is vehicle systems design, where you got to understand a lot of very complex college stuff to be able to do it. That's pretty hard generally for all of the most advanced high school students. One notch below that, I'll call it detail designing on CAD, where you're coming up with parts according to direction that you received from somebody. The third level is, we call it making drawings, where the CAD design is done, but you take the CAD pattern and then you create a drawing. In a later topic next week, we'll talk about what do those numbers mean when you put numbers on the drawing so that we're able to correctly interpret what the build sequence should be from reading the drawing. But for now, with a very young team, to get people involved in CAD, what I would like to do is I would like to have you prepare the drawings from the CAD model, that first step. Then as our skills develop and as we work together well, the CAD team would then move up to the point where they're starting to do detailed design according to direction, and then at a senior level, move to the point where you're able to actually design system level the robot. The reason the system level is harder is it involves all the disciplines, not just mechanical or electrical. You have to have everything work together so the robot works when you're done. In the electrical, so that's how we plan to work it in the mechanical area, where we're going to build several projects. I know we have a sync project. There is a project related to a cart that I wanted to talk to Peyton more about tonight. And then we could possibly build a prototype robot that might look at things that are of interest. So now let's go to the electrical area. The same thing kind of carries over. You have to have a lot of skilled knowledge to design an electrical control system for a robot. However, mercifully, FIRST has already done much of that for us in their provision of the part kit. They have assured us by specifying those parts that if you hook a sim to a Jaguar and run it in this way, that it will actually perform well. That saves a lot of pain and agony, because if you just go buy motors from a magazine or something like that, all bets are off. You don't know that when you hook that motor up to that drive that it's going to be stable or proper in its operation. So in the electrical area, the way we most prepare is to get used to understanding the safety and the wiring standards and what's required, and practice those things on and become familiar with the tools. In the software area, there's a lot of intense work with regards to a FIRST robot. user interface is a big part of that. There, the software designers prepare how the controls work to control the robot. I think what they need most is to understand to some degree what are the sorts of things that we would be looking for in a mechanical system and an electrical system, so that if there's some special software, say traction control for example, that they would know and have that done ahead of time. The way you do a good efficient job at the robot is not by being super people, supermen, superwomen. When the robot is being built, it's by being prepped ahead of time to where you know what to do. So if you think about between now and January, when we get our game rules, we will have built several things and be very comfortable and confident that when we get the game, it's just like the practice builds. Okay, and that's it, I think.